Today we're going to learn about the importance of function notation and what it is. So we're going to talk about what a function is. We'll talk about the function test and the function notation. Let's get ready. You're going to need notes, paper, and a calculator, and be sure to take notes on the last slide. I'm asking you what you notice. On the left, those are all functions. On the right, those are not functions. If you notice, they seem to all have arrowheads except for the circle. What else do you notice? Well, the ones that aren't functions seem to kind of like fold on themselves, kind of. I want you to keep that in mind, but these ones don't, not up and down anyways. So what happens is when you have a function, for every x, so if I come over to x is 1, there's one value. And when x is 1, there's one value. And when x is 1, there's one value on all of those. But what happens when x is 1 over here is there's two possible y values and two possible y values, or 3 or 2. So it's going to be a function if for every x there is exactly one y, only one y. If we think about the function in the middle, and we call that like a machine, f of x, you put in something, which is my domain, you put it in, you do something to it, and then you get the output, which is the range, which is represented by y. So a function is a relation in which each input has exactly one output. We have the vertical line test for it. So if I can draw a vertical line anywhere through and only pass through once, then these are all functions. But here I pass through twice, and here I pass through twice, and 3 times, and twice. So these are not functions because they fail the vertical line test. How to test if it's a function given a table of data. So take a minute and look at these tables on the left. It is a function. On the right, it's not a function. And if you notice on the left, my x's are getting bigger. Those are going up. And I have 4, 6, 8, 10, 12. I'm going up by 2 each time. Okay. But when I look at my y's, my second one, when x is negative 1, y could be 4 or y could be 2. And when x is 0, y could be 6 or y could be negative 3. So that one's going to fail because I have x's assigned to more than one y's. The functions we're going to be studying this year in Algebra 2 are linear when we have x to the 1, quadratic is x2 squared, cubic is x cubed, square root, cube root, exponential, logarithmic, and inverse. Function notation is how we name functions. So if I know something is a function, I can name it f of x, another name is g of x, h of x. It's kind of like Fred, George, and Harry. I clipped a little bit from Desmos just to show you. If I just gave you this graph on the right, you might not know which equation is what, but because it's color-coded, the red equation goes with f of x. So this red equation is f of x. And that has the negative slope, and it has a y-intercept of 3. So function notation is a way of naming a function so that you can then use it in the future. If I look at this equation, I'm given f of x equals negative x plus 3. So I'm given the equation, and I can plug in the table. So we're used to our table being x and y, but notice that y is f of x. It's just the function that I put it into. I put x into the equation and I get y out of the equation. So these need to get into your notes. A function is a relation in which each input x is paired with exactly one output y. We have the vertical line test. If a vertical line passes through the line or the function exactly once, then it is a function. Is a function. And function notation, f of x, g of x, h of x, which names them. And you evaluate functions by plugging in x, which would plug in here, and then it's outputting y. This whole thing is y.